Welcome to part 2 of the video series. So we're going to start filling out the table of values presented here. And again, I only go from 0 to 4, but just this table can also deal with negative numbers for the x value. So how do we calculate the y value when x is 0? So you just simply substitute into your equation and solve for y, like we were used to in the previous units. So in this case, we get 0 minus 3, so y equals negative 3. If we substitute a 1 for x, we get 3 minus 3, which we get 0 for y. If we substitute 2 for x, we get 6 minus 3, which gives us 3. And I can continue with the pattern, so as long as you're following through, you can check the work. The next value is going to be 3 and 9. So it's increasing by 3s. Let's do the same thing that we did in the other table. If we do the same thing, we substitute the values for x into the equation. When we substitute x, we get 3 times negative 1 gives us negative 3. When we substitute a 1 into the equation, we get 1 minus 1 in the bracket, so 3 times 0, which gives us 0. When we substitute a 2 into the equation, we get 2 minus 1 inside the bracket, which becomes 1, and we get 3. And you continue this, and you should get 6 and 9. So question 2 says, what do you notice about the tables compare? Well, the tables, the similarities are that all the x and y values are equal. What's different is that the equations look different. So the next thing that I ask you is to graph. So to show you, here's our graph for graph 1. And here's our graph for graph 2. And as you can see, both graphs are identical. You can put them side by side or on top of each other. They come out to be the same values. Now, I wanted you to continue to graph I wanted you to graph also on the negative x values, so going down here. So all you have to do is just extend your line of best fit through your scatter plot and go down to the negative, because the pattern increase is also part of the negative, or quadrant 3. So now we're going to come up with some relation for question 4. Question 4 asks, well, what do you notice about the lines? Do you think the lines are the same or different? Make sure that the scales are the same. The scales are the same. So according to both graphs and the tables, it appears that the lines are the same. So is it possible that y equals 3x minus 3 is the same as y equals 3 times x minus 1? Are they the same? And by the end of today's lesson, we should be able to answer that question. Looking at them visually, through the table model, through the graphical model, they look to be the same. But the algebraic model, they look different. So are they in fact the same? So let's start with the first part of our lesson, which is distribution with algebra tiles. So before we start learning the distribution property, we're going to start doing a problem that involves algebra tiles. So again, I'm going to relate it to something you know. We know area. So to maintain FIFA soccer regulations, a soccer field must have a length double the width plus 3 meters. So if the width is 2 meters, so I'm going to start placing the tiles for the width, 2 meters. Determine the length of the field. So I'll give you a minute to jot that down. So if the width is 2 meters, what happens to the length? The length has to be double the width plus 3 meters. So in this case, the length is 2 times the width, which is 2 meters, plus 3. So our length is going to be 4 plus 3, which gives us 7. So now what we're going to do is, with the tiles you see on your little grid there, I'm going to create the length and the width. And you can just draw a little rough sketch of the tiles on your piece of paper. So I'm putting 7 tiles for the length and 2 tiles for the width. Now, we're going to determine the area of this shape. So what shapes can I fill to create the area? Now, we can't use the lawn tiles because the lawn tiles, we know, don't add up to 4 or 5 of the small tiles. So what we're going to have to do is we're going to start filling the shape with these single tiles. So how many single tiles do we need to create to fill the shape? Well, based on what our answer is, yeah, we're going to need the same amount for the length and for the width. So I'm going to try to copy these, make it easier for us to calculate here. So just keep on drawing your little boxes. And again, the tiles again are more of a visual. Do I want you to use tiles on a test? Although you can use tiles and I can pull them out. I prefer you to do these problems more algebraically without the support of the tiles. But if you need them, it's another way of doing it. So the area of the soccer field would be, how many tiles do we have in the area? Well, according to this, we have 2 by 7, so the area in this case would be 14 meters squared. So let's go on to the next page. So you copy that down. If you have to pause at any moment, you can, but really this part you should be already all done. So now we're not going to use numbers. We're using variables for the next part. Welcome to part 3 of the series. And what you're going to be doing next is this next page here that I'm showing, the distribution property. You're going to come up with this investigation to come up with a quicker way to determine the area of multiplying 2 different expressions together. So the first one's pretty much done for you, where I have a rectangle which has a width of 2, which is, you see it on the vertical side, and the length of x plus 1. So there's our x, there's our 1, and this is 1 and 1, which gives us x plus 1, and our width is 2. Well, what tiles did we need to create that area? Well, we needed 2 x tiles and 2 single tiles. So when we work this out, our area is what? Well, I have 2x tiles plus 2 units tiles. So that's where we get an area of 2x plus 2. So now when I show it as length times width or width times length equals area, we get the following, where 2 represents the width, x plus 1 represents the length, and area represents 2x plus 2. Is there a quicker way to go from here to the area form, or and we call that the expanded form? So what you're going to do now for the next few minutes is you're going to work either on your own or with someone quietly. You're going to complete the rest of the table and fill out all the unknowns on the table, and you're going to answer question 2 and question 3. Question 2 explains what the shortcut is. So I'm hoping you figure out what to do and how to solve these types of problems. Okay, so I'll put it on pause, and you can stop video 2 in 10 minutes. I want you to put up video, this is video 3. In 10 minutes, you're going to put up video 4. If people are finished before 10 minutes, you can put it up within 5 minutes or so. Okay, so we'll put it on stop. Okay, I'm assuming that you've done the activity presented to you. Fill out the table, so 10 minutes or less have passed, and now we're going to start taking up the table. So I've done the second row, and as you can see, we had to fill out the width and the length. And in this case, I was giving you the area, which was in the middle part, and now the width in this case is x, and the length is x plus 3. So we have x plus 3 as our length. So when we unveil the width, we get a width of x, length of x plus 3. And when we figure out the area in this case, we get x squared plus 3x. So the area is x squared plus 3x. When we write it in equation form of length times width, we get x times x plus 3 equals x squared plus 3x. So how do we get from this form to the expanded form, or the area form? Let's take a look at the next answer. Well, the next answer, I give you the length, which is x1, which is equal to x, which is equal to 2x plus 1 is the length, and the width is equal to x plus x, which is equal to 2x. When we fill it in with the area, we have to use the big tiles. Okay, so we're using 4 big tiles plus 2 long tiles. So that means our area for this is 4x squared plus 2x. So when we work this out, we know that the width is 2x, the length is 2x plus 1, the area is 4x squared plus 2x, and when we write it in equation form, the width is 2x, the length is 2x plus 1, and the area is 4x squared plus 2x. This is called expanded form. And when we finally do the last row, we get the following. The last row, I don't give you anything. I give you the length and the width. So the length is x plus 3, and the width is 2x. When we fill it out with the area, we have to use 2 big tiles, x squared tiles, and we fill the rest with 6x tiles. So the area works out to 2x squared plus 6x. So when we unveil the area cell, we get 2x squared plus 6x, and in equation format, we get 2x times x plus 3 equals 2x squared plus 6x. So now I'm hoping you see a pattern here. Well, what's happening here? How do we get from this form to that form? Well, I'm going to scroll all the way to number 1, and you'll have a time to copy it. Take a look what's happening here. The 2, it looks like, is doubling both the x and the 1. So we're multiplying the 2 into both of those terms. So it becomes 2 times x plus 2 times 1, which is 2x plus 1. And in this case, the x is being multiplied into the x and to the 3. So x times x becomes x squared, plus, because that's the sign there, x times 3, which is 3x. Does that apply for the next one below? If we follow suit, move that out of the way, 2x times 2x plus 2x times 1. 2x times 2x is 4x squared. 2x times 1 is 2x. So it applies for the next one and also for the last one. 2x times x, 2x times 3, we get 2x squared plus 6x. So we found the relationship and how to determine, how to expand, how to find the area. So we're going to answer that for question 2. It says, look at the last column. And again, if you need to go back here and rewind or put on pause to copy it down, you can. But you should all have this. So I'll just keep this up a minute. If you need to pause it for a minute to copy down, you can. And we're going to answer question 2. So question 2 says, look at the last column. Describe how you can start with the expression on the left and left of the side of the equation, get the expression on the right side of the equation. So I'm going to write it down as this. If I have A times B plus C, I'm going to get A times B plus A times C. We multiply the A with both the terms, or as many terms as there are inside the bracket. This is called the factored form. And this is called the expanded form. And that's the answer for question 2. Okay, now I'm going to go to question 3. These are all question 3s. And I have the tiles here to help us if needed. We're just going to do one example with tile. which is actually we're going to do question B, question 3B using tiles and without tiles. So question 3B, well, how would we present x times x plus 7? And actually 3B, we won't do 3B with the tiles. We are going to actually do question 3C with the tiles. Okay, so we're going to do 3x times x plus 2. So the width is 3x. And as you can see, I can't even fit the width here. And the length is x plus 2. So what do we need to fill out the rest of this for the area? Well, the area gets 1. We get 3x squared tiles. And we're going to get a bunch of the x tiles. So now, without using distribution, we use the tiles. We get an area for 3C. Area equals 3x squared plus 1, 2, 3, 4, 5, 6, 6. But you can see you're not going to always have a pocket full of tiles with you, although some of you might. So how do we do these questions in 3 without tiles? Well, let's take a look at 3A. So 3A is 4 times x plus 3. Well, how do we use distribution to expand that expression? Well, we get 4 times x, which is 4x, plus 4 times 3, which is 12. So I want you to work on 3B and 3C. And you have the answer for 3C. I want you to make sure that you can do that with distribution. And I want you to do 3B with distribution. And as you're doing it, I will work on it on the side. Okay, so now you know how to solve problems using distribution. I'm going to stop this. This is part 5 of the video series, part 5. So you've done those questions from the previous page, those 3 questions, A, B, and C. Now I'm going to show you another tool how to distribute, instead of doing it with the arrows. Some people might have trouble with using arrows, especially when you're dealing with integers, negatives, and positives. This is another tool. As I told you before in the past, I like showing you different ways of doing something, and you pick the one that you excel with. So how would we expand 4 times 2x minus 4? I'm going to still treat this as our width, and that's our length. So in this case, I'm going to put the width, all the terms of the width along up and down here of the first column, and the length, all the terms of the length will be placed across this row. So the width is only composed of 1 term. So in this case, it's a 4. The length is composed of 2x and a negative 4. So what's nice about the table is you simply just multiply to get the value in this cell. You multiply the 2x times the 4. To get the answer in that cell, you multiply the 4 times a negative 4. So that's what we're going to do now. So in this case, 4 times 2x, we get 8x. 4 times negative 4, we get negative 16. So in this box here, and it looks nicer on your table where it's like not as bolded, that represents the area. So the simplified form, when I expand this, I get 8x minus 16. So that's another way to expand or to use distribution. So I just want you to take a minute. You can put it on pause. Whoever's in charge, put it on pause. Give you a couple of minutes to fill out the chart, and we're going to show you the answers. Okay, now I'm back. So in this case, the width is -3, the length is 4x, and -5. When we multiply the -3 with the 4x, we get -12x. When we multiply the -3 with the -5, we get the +15. So when we expand, when we simplify this, we get -12x plus 15. Again, another way of using distribution. And you can figure out the last one on the chart there in your table. Okay. So the next two examples you can copy down, and it's just expand and simplify. So how do we, I prefer using the distribution method, the arrows, as opposed to the table or the algebra tiles. But again, if you need those for support, you can use them. So what are we doing in this case? So our first step is to multiply the 8 with both. And by the way, this is on the second page, so now it's on the bottom where it says distribution property, algebraic method. So we're doing question A. So I'm multiplying the -8 with both the 2 and the -x. So step 1 in our solution. Again, you will not have to show this eventually. You're going to get quicker and you don't have to show all these little steps. But I'm showing it so you know exactly what's happening. I have -8 times 2. And remember how last day we said it's always you're adding terms. You were counting tiles plus -8 times -x. When we simplify that, we get -16 plus +8 because -8 times -x is positive. And we don't like keeping double positives. We combine the integers, the signs. So we get -16 plus 8x. And if you recall from last day, whenever we're presenting a solution to an expression, always the greater degree goes first. So we have 8x plus -16, and then we don't like writing it as 8x plus -16. We just simply write it as 8x minus 16. So eventually, you guys can probably go from this step all the way down to this step, and then down to your answer. So maybe 2 steps, if 1 step, to get your answer. Okay, so I'll give you a minute just to copy that down. Okay, we're going to proceed to the next example. If you need to pause it now, you can, but you should have all copied this down. I'm going to be posting this online as well, so if you miss any part of this lesson, the videos are already there, so you can watch the video online. We're going on to the next part. It's the distribution property again. So, well, what do we do now? In this case, we have 3 terms in our length part of the expression. So we have to multiply the -5h with the 3h squared, -5h with the -7h, -5h with the -2. So we're going to multiply those that term, the -5h, with those 3 terms inside the bracket. So I'm going to try to do the shortcut method in this example, because last time I showed it with integers. I'm going to go back 1 step. So just to show you these last solutions, I showed all the integer values and the signs, okay? Now I'm going to try to show you a quicker way so you don't have to worry about putting the integer signs as much. You just have to deal with either it's a negative or it's a positive. If you don't like to do it this way, stick with the first way I showed you with this question A. Okay, so step 1, we're going to expand. So -5h times 3h squared. Again, we're multiplying like bases. So it's going to get -15h cubed. We multiply the -5h, multiply the -5h with the -7h, we're going to get positive 35h squared, and -5h times -2, we should get positive 10h. So I showed it how we're doing. We're adding terms or we're adding tiles. Again, you don't have to show this step. If you want, you can go right directly to the next step here. So we get 15h cubed plus positive 35h squared plus positive 10h. Or you can simply go right to the solution in this case. 15h squared plus 15h cubed plus 35h squared plus 10h. So technically, if you're comfortable with this, you can go from this to that step and no problem and get your 3 marks for each of those terms. Okay, so what you're going to be doing is you're going to finish off the examples on the worksheet, questions 1, 2, and 3. And unfortunately on the worksheet, I think it repeats 3 twice. I am going to cover the last 2 examples on the worksheet. So you can work on that for the rest of the period. And once you're done that, you're going to work on the assigned homework, which I'm going to show you. Actually, I might as well post it right now. Your homework is right here. Section 3.7 of the textbook, numbers 3 to 5, do every other letter for 3 to 5. 7 BF, 8 ACE, 9 ACE, 10, 13, 15 FGH, 16 CD, and 17. It seems like a lot, but most of these questions are really quick and easily done. Okay, so once you get the hang of distribution, it really is quick and fun. Okay, so I will post those answers, those questions over here again. So you always see it at the bottom of the screen. There's your homework. And if you finish that, you can start doing the review, the entire review of Unit 3, and practice with the chapter test as well. So you can do that for further practice. It's all the review section. Okay, so now we're going to do question 2. We're going to do question A and question B by pencil and paper method. So I'm going to try to do more of a shortcut method. So now we have 2 sets of distributions in this expression. So how do we deal with it? You deal with it like you normally deal with one. You just deal with them both one at a time. So when I expand, the 2x is going to multiply with the x and the negative 5. And the negative 3x is going to multiply with the negative 3x with the x and with the 1. So when we expand this, we get 2x times x, which is 2x squared. So I'm not going to try to do all these calculations quickly. Plus 2x times negative 5 is negative 10x. Plus negative 3x times x is negative 3x squared. Plus negative 3x times positive 1 is negative 3x. Now I'm going to change these, and as we saw last lesson, we like to collect like terms. So I'm going to put all the like terms together. So we get 2x squared, and now I'm going to combine the integers, minus 3x squared minus 10x minus 3x. So I got rid of those addition signs and change it to either positives or negatives. So 2x squared minus 3x squared, well, we get negative x squared, or negative 1x squared. We don't show the 1. Negative 10x minus 3x is negative 13x. Okay, we're going to do question B as you're copying that down. Now we have fractions, and you guys freak out with fractions, but you know the rules already. So just follow the fraction rules and everything should be good. So we're going to do the same thing. And this time we're keeping the fractions. Don't change your answers to a decimal. I'm going to multiply the 2/3 into the 3x and the negative 1. I'm going to multiply the 1/2 into the 4x and into the 3. So let's show this. 2/3, and I'm going to show each step for this one because this one requires a little bit more work, times 3x plus 2/3 times negative 1 plus 1/2 times 4x plus 1/2 times 3. So when we work with this, we're multiplying the numerators. So basically the 3x and the 2 multiply together, and the denominator stays as 3. So 2 times 3x becomes 6x over 3, plus negative 1 times 2 becomes negative 2 over 3. And I'm going to keep that as a bracket because we have a negative. plus 1/2 times 4x. We just multiply numerator with numerator. It becomes 4x over 2, if you want to keep it as a bracket. And if you want to put a plus there, you can, to show that it's positive. Plus 1/2 times 3, which is positive 3 over 2. We're going to collect all our like terms. 6x over 3 plus 4x over 2. And instead of showing plus negative, I'm just going to put it as negative 2/3 positive 3 over 2. So again, how can we add fractions? Well, we need the same denominator. So for the first two, the common denominator in this case would be 6. So what do we get? What do we have to multiply the denominator 3 by to get 6? Yeah, we multiply it by 2. Whatever you do to the denominator, you must do to the numerator. Same thing for this one. These two I want to add together. So I multiply this by 3 and then that by 3. Now, how do we add these two like terms together? Again, the denominators must be the same. So the common denominator in this case is 6. Multiply that by 2 and the numerator by 2. And the second fraction, multiply the denominator by 3 and the numerator by 3. So when we work this out, we get 12x over 6 plus 12x over 6 minus 4 over 6 plus 9 over 6. There. So we only can add like terms together. Well, 12x plus 12x, and whenever we're adding fractions, we only add numerators. We get 24x over 6. What's negative 4 plus 9? Well, we're going to get plus or positive 5 over 6. Then you ask yourself, can you simplify any of these fractions? Well, the first fraction can be easily simplified. 6 goes into 24 nicely. 24 divided by 6 becomes 4. So now we get 4x plus 5 over 6 is the expanded form. Okay, and that's it from me. Everyone have yourself an amazing weekend, and hopefully you pick things up. If not, these lessons are online to go over again, and please do your homework. That's assigned through section 3.7. If you finish 3.7 in class today, work on the review and work on the chapter test, because we'll probably have a day just for you to ask questions on Tuesday, and your test will be Wednesday. Have a good day, everyone.